What does the phrase inverse cosine mean? Let's check it out. Here we have the unit circle with radius of 1. Watch this. Here we're going to take the cosine of that theta, which is the x-coordinate, see? And we're going to drag that along here. And we're going to input that into that function right there. Next, we're going to take that angle theta. The radius of that circle is 1 on the left side, so let's just unravel it out. That arc length there is the same as that angle value there. But look at this. When we say inverse cosine of x, the inverse cosine is actually an angle. All right? So right here, look at this. Let's watch this carefully again, because this tells you everything you need to know. Right here, when we take this, we are inputting, right? We're inputting the ratio. We're inputting the cosine ratio. And right here, we have an output now of an angle. So inverse cosine of x right there, that output is an angle. Or inverse cosine of x literally means in English, angle whose cosine ratio is x. You see what I mean? If I were to actually rewind this and take it, and let's actually get rid of this, this, and this. Watch. All right, let's make the angle a little bit smaller. Let's make it acute now. The hypotenuse of that right triangle is 1, and so therefore the radius of the circle is 1. Look at this. We're going to input that theta right there. Input that ratio, the cosine of theta. And now we're going to output the angle theta, so that theta is an output. The same is true for the inverse sine graph. Look at this. Here we have a radius of 1. Watch. Here we're going to input the sine of theta as our x value, and the output, or the y value, is the angle. Right? So inverse sine, right, literally means angle whose sine ratio is x. Same logic with inverse tangent. See? Here we go. Take the tangent ratio, we'll put it right there, and look at that theta. That's the output right there. And there you go. So inverse sine, inverse cosine, inverse tangent simply mean angle.